Good morning, student. So this is our next tutorial on the same chapter, matter. You see, in the previous video we have discussed how the particles are arranged in different states of matter. We have seen solid, liquid and gas. In solid, the particles were very tightly packed. In liquid, the particles are less tightly packed, and in gas, the particles are very far away from each other. As in solid, the particles were very tightly packed, so interatomic force was maximum, that is interparticle force is maximum in case of solid. As in case of liquid, you see the particles are less closely packed as compared to solid, so intermolecular force or interparticle force is less as compared to solid, and interparticular force is least in case of gas. So in today's video we will find that how one state is getting changed into another due to absorption or release of heat. So matter changes from one state to another either by absorbing energy or by releasing energy. The whole process takes place without any change in temperature. So when a matter changes from one state to another without any change in temperature in itself is considered to be as latent heat of fusion, right? So let's take one example, then we'll go on the topic, that is our main topic here, latent heat. What is latent heat here? So let's understand this term with one example. Let us consider we have a glass is containing some juice, right? So in that juice, if you pour ice, you will find that the temperature of that soft drink is decreasing. The temperature is decreasing, it is getting colder. But you see, the ice which is melting at 0 degrees Celsius, it keeps on melting without any change in temperature in itself. That means ice itself, it melts in 0 degrees Celsius. It does not change its temperature. On the other hand, the liquid which is inside the glass, its temperature gets decreased. Its temperature is changing, but the temperature of ice is not changing here. It itself is melting at 0 degrees Celsius. So this is called latent heat of fusion. So let's see what is latent heat of fusion. The amount of heat absorbed or released when a substance undergoes a change of state without any change in temperature. That means, you see, a matter is changing its state from one state to another, that means that solid to liquid, right? That ice is melting from solid to liquid, but itself, its temperature is not getting changed. So this is called latent heat. So latent heat can be latent heat of fusion. So when I say latent heat of fusion, this term we use either absorption of heat or release of heat. If a ice is absorbing heat of 336 into 10 to the power 3 joule per kg, right? If an ice is absorbing this much of heat, it gets melted. That means on absorption of heat of this much, that is 336 into 10 to the power 3 joule per kg, that ice is melting into water. Okay, so absorption of heat changes into water. Similarly, 1 kg of water, it will release 3 into, that is 336 into 10 to the power 3 joule per kg of energy. Okay, so this is latent heat of fusion, right? Specific latent heat. If the amount of matter changing state is a unit mass, we use the term specific latent heat. You see, just now I said that when a matter is changing its state from solid to liquid without change its temperature, either by absorbing energy or by releasing energy, this is called latent heat of fusion. Okay, so in a simple words, latent heat of fusion can be due to absorption of heat or due to release of heat. But when I say specific latent heat, that means 1 unit mass of a substance is changing from solid to liquid, or 1 unit mass of substance is changing from liquid to solid. Okay, so here you see the SI unit is joule per kg. Okay, if 1 kg of ice is changing from its solid state to liquid state, that is water, we considered as specific latent heat of fusion. Okay, because that 1 kg of ice is absorbing energy and it is changing from solid state to liquid state. Specific because it is 1 kg. So whenever I consider 1 unit mass, we have to use the word specific latent heat. Okay, here I have given one example. The specific latent heat of fusion of ice is 336 into 10 to the power 3 joule per kg. What does this term mean? That means 336 into 10 to the power 3 joule per kg means what? This means 1 kg of ice absorbs 336 into 10 to the power 3 joule of energy to get into change into water. Okay, so this is called specific latent heat of fusion of ice. So here you see I have written here latent heat of vaporization. State of matter can be solid, liquid or gas. Yes or no? So in latent heat of fusion we have seen the substance is changing from solid to liquid or from liquid to solid. Here in latent heat of vaporization means here when a state of matter is in a liquid state. Suppose 1 kg of water. 1 kg of water, it will absorb energy and it will get changed from liquid to gaseous state. So whether the substance is changing from liquid to gaseous state or a vapor state or from vapor to liquid state, so we consider to be as latent heat of vaporization. See what I have written here. It is the amount of heat absorbed or released due to change of a substance from liquid to vapor or from vapor to liquid without any change in temperature. Without any change in temperature is considered to be as latent heat of vaporization. So if I say specific latent heat of vaporization of water is 2260 into 10 to the power 3 joule per kg, what does this mean? This means that 1 kg of water absorb 2260 into 10 to the power 3 joule per kg of water to get change into vapor state. That means 1 kg of water will absorb this much energy, then only it will get to vapor state, right? So what it is doing, it is absorbing energy. Now in case if I say what is a specific latent heat of vaporization of vapor, in case of water if I say vapor, what is the specific latent heat of vaporization of vapor, then you will be saying that the gas which is in unit mass, that is 1 kg of gas molecules, will release energy of 2260 into 10 to the 3 joule of energy to change into again water state. Okay, so in the screen you can see the definitions of latent heat and latent heat of fusion, that is a matter is changing from solid to liquid or from liquid to solid, which I have already explained. Next topic you see latent heat of vaporization. Just now I said it is the amount of heat absorbed or released to change a substance from liquid to vapor or gas, or from vapor or gas to liquid without any change in temperature. So its temperature is not getting changed, but its state is getting changed from liquid to vapor or from vapor to liquid. So the example also I gave that if we consider 1 kg of water absorbs 2260 into 10 to the power 3 joule of heat energy to change into water vapor, that means it is absorbing this much energy. And if I say 1 kg of water vapor releases 2260 into 10 to the power 3 joule of heat energy. This means it is a latent heat of vaporization of water vapor. Okay, this all you need to note down in your exercise book. Okay, so the next topic which we will see here, that is called advantage of having high latent heat of fusion of ice. So soft drinks, if you place water at 0 degree Celsius as well as ice of 0 degree Celsius, you will find that on adding ice, the temperature of the soft drink is reducing fast as compared to cold water. If you add cold water, then the temperature will not decrease as fast as on adding ice. So this is one advantage. Similarly, you will find that next advantage, snow melts slowly on the mountain slopes in summer, as every gram of ice needs 336 joule of heat energy to melt, and this prevents flood. So this is also one advantage of having high latent heat. Water bodies such as rivers and lakes do not freeze suddenly in winter, as every gram of water has to release 336 joule of heat energy. So this is another advantage. So these advantages you need to note down in your copy. You can note down 3 advantages. Okay. So next, effect of high latent heat of vaporization of water. Burns caused by steam are more serious than burn caused by boiling water, as 1 gram of steam has 2260 joule more heat than 1 gram of water at 100 degrees Celsius. So these are the effect of latent heat of fusion. A boiling water will create a less impact than that of vapor. A vapor which is at very high temperature, it has more energy, that is 2260 joule of energy, more energy than that of boiling water. So a vapor will always create a high impact on your skin. It will create a more severe burn as compared to boiling water, which is at 100 degrees Celsius, because the absorption of heat of vapor is very large as compared to that of boiling water at 100 degrees Celsius. So this is also one effect, and the notes which I have shown you, that are the advantages of latent heat of fusion, right? So here in the board you can see that I have drawn a block diagram of solid, liquid and gas and the interchange between them. When we supply any heat energy to any solid, the molecules or the particles, they try to move away from each other, and the arrangement of the particles gets disturbed. So what happens here, solid gets changed into liquid, and that process we consider to be as melting. So what is melting here? It is a process in which a substance which is at solid state changes into liquid state, and this change takes place at a particular point of temperature, that is called melting point. So melting point is the particular temperature at which the solid gets changed into liquid, right? We know the melting point of ice is 0 degrees Celsius. This means ice is changing from a solid state to liquid state at 0 degrees Celsius. Here. Similarly, if a liquid is changing into gas, we consider to be as vaporization. So it is a process in which a substance is changing from liquid state to gaseous state. That process is considered to be as vaporization. Now vaporization can be of two types here. You see, a change of state from liquid to gas, it can be evaporation and it can be boiling, right? So these two terms, they are very different from each other. Like though they are converting from liquid to gaseous state, these two terms are different. I repeat, boiling and evaporation. First difference which you see in boiling, that boiling takes place at a particular temperature. When you heat any water, this water will change into liquid state at a particular temperature, that is at 100 degrees Celsius we consider to be as boiling point. Similarly, in case of evaporation, when a substance changes from liquid to gaseous state, it can change over a wide range of temperature. It does not depend upon a particular temperature. It can change anytime, like a river, lakes, ponds. These all water bodies, in the daytime or in the night time, there is an escape of water molecules from its surface. So this is called evaporation, the process in which the liquid changes from liquid state to the gaseous state without any particular temperature. At any temperature we consider to be as evaporation. So liquid to gaseous. If a solid is changing from a substance in solid is changing from solid state to gaseous state, we consider to be as sublimation. So what is sublimation here? It is a process in which a substance changes from its solid state to gaseous state without any change in temperature. That means here it is not changing into liquid state, right? Without any change in temperature, as well as it is not undergoing the liquid state. Directly it is changing from solid to gaseous state. That is called sublimation. Okay. Similarly, if a substance is changing from gaseous state to solid state without changing into liquid state, we consider to be as desublimation. If you change gas into liquid, we consider to be as condensation. Okay, so these are the different change of state. Liquid is changing into gas, whether it can be by boiling or by evaporation. It depends upon a temperature. If it is taking place at a particular temperature, we consider to be as boiling. If it is not taking place in a particular temperature, it is changing in any temperature, we consider to be as evaporation. So this is the physical change of state, right? So it is a reversible reaction. Evaporation, boiling, melting, freezing, condensation and sublimation are the examples of physical changes. And just now I have explained what is vaporization. It is a change of substance from a liquid state to gaseous state by absorption of heat. Also, vaporization can be of two types, that is evaporation, that takes place at over a range of temperature. That means it does not depend upon a particular temperature, and it takes place that is of below boiling point. 100 degrees Celsius is the boiling point of water, and below 100 degrees Celsius also the water of lakes and river, they get evaporated in the atmosphere, right? It gets evaporated. Also, so you will be writing a short point or a definition of vaporization, evaporation from the note. Also, what is boiling? It is a rapid change of state from liquid to vapor state at a particular temperature. So this is also one more example or a difference between boiling and evaporation. In boiling, we'll find that it is a rapid process, liquid to gaseous, rapid process, but in case of evaporation it is slow process. Also in boiling there is a formation of bubbles, which we don't see in case of evaporation. Bubble formation is not there, right? In the right hand side you will find that evaporation and boiling, these differences you need to note down in your exercise book. Okay, evaporation is a natural and slow process. It is a fast process. It takes place at all temperature. It takes place at boiling point. Bubbles are not formed, and boiling, it is accompanied by formation of bubbles. It occurs at the surface of liquid, and boiling, it occurs throughout the mass of the liquid. And evaporation, it causes cooling effect, and it does not cause any cooling effect. Condensation also you will be writing in your copy. That is a change of state from gaseous into liquid by giving out heat energy. So substance is changing from gas to liquid by releasing energy, that is heat energy. Next we find melting point. The temperature at which a solid changes completely into liquid is called melting point. Similarly, solidification, the change of state from liquid to solid by release of heat. That means on release of heat, a substance is changing from liquid to solid again, not into gas, right? Liquid to solid, that is called freezing. And sublimation, it is a change of state from a solid to gas without passing through liquid phase. So other name of desublimation is deposition. That is, a substance is changing from gas to solid. Just now in board I have explained a substance is changing from gaseous to solid state, that was desublimation. Here the another name of desublimation is deposition. Okay, you can note down one example. So change of state diagram. So this is a change of state of diagram. You see, initially the substance was at 0. We can consider here the substance is at 0 now. As you increase the temperature, the solid starts melting, and that total solid is converting into liquid at a particular temperature, that is called a melting point. You see here. So at a melting point, again if you increase the heat energy, that means in this side, this is the x-axis we have heat, and y-axis we have temperature, right? On increasing the heat, the temperature also gets increased. So as the heat is increasing, the substance is changing from solid to liquid, that is on melting, right? And on further increase in temperature, the liquid starts converting into vapor state, that is vaporization. And the letters which is written in red, you see, that is the reverse process. That means gas, if it is changing into liquid, that is called condensing or condensation, or if a liquid is changing into solid, that is called freezing. Okay, so this diagram is said to be a change of state diagram for melting, vaporization, condensation and freezing. So this is our end of our chapter, that is matter. We have seen what is matter, what are the arrangement of solid, liquid and gas, how they differ from each other, also how this change is taking place from solid to liquid or from liquid to gas on absorption of heat or by release of heat, when we say latent heat of fusion, latent heat of vaporization, and physical change of state, that is sublimation, desublimation, also known as deposition, melting, boiling, evaporation. These terms you need to note down in your exercise book. Also I will be giving some pictures of the textbook in your WhatsApp group, so you will note down as a note, right? Also some exercise questions I will be giving in your WhatsApp group. Okay.